All right, so now we are now in 6.4, where we are going to be solving systems by reducing matrices. Okay, let's recall, a quick recall. If we have 2x1 plus 5x2 equals to 4, and then 8x1 plus 3s2 equals to 7. The coefficient matrix, we call this the coefficient matrix, is 2, 5, 8, 3. That is the coefficient matrix. This is called the coefficient matrix. Okay, now, by the time we include the right-hand side of the equation into the coefficient matrix, that is what we call the augmented coefficient matrix. Okay, and that is giving us 2, 5, 8, 3, then 4, 7. Okay, this is what we call augmented coefficient matrix, but this is what we call coefficient matrix. All right, so first you need to bring out the augmented coefficient matrix from your system of equation, and then you can now perform what you call elementary roll operation on them. This elementary roll operation has 3 rules. Number 1, you can only interchange 2 rows of a matrix. So if there is a matrix like this, this row is row 1, this is row 2. Okay, you can interchange 2 rows of a matrix. The sign for interchanging is this. So you have a double arrow. You can interchange 2 rows of a matrix. Number 2, you multiply a row of a matrix by a non-zero number. You multiply the row of a matrix by a number. So you can have 3 row 1. That means you are only multiplying row 1 by 3. Or you can have 2 row 2. Or you can even have 1 over 2 row 1, depending on what the operation you are performing. Please take note, you can multiply by a number. You cannot multiply a row by another row. Please, that is not permitted. You cannot multiply a row by another row. You can only multiply a row by a number. And then the last one is that you can add 1 row to another one. So you can say 3 row 1 plus 2 row 2. You can add this together. So these are the 3 operations you can perform whenever we're doing elementary roll operations. Okay, so we are going to be using this elementary roll operation to reduce the matrices. And how do we know a reduced matrix? Number 1, all the 0 rows are at the bottom of the matrix. If they are all zeros, they must be at the bottom of the matrix. Number 2, for each non-zero, when we say non-zero, we mean it is not a 0. Okay, for each non-zero, the leading entry is 1. The leading entry must be 1. And all other entries in the column of the leading entry are 0. So anytime we have 1, the remaining element in that column should be 0. Okay. Number 3, the leading entry in each row is to be to the right of the leading entry in any order above it. So when we have leading entry 1, any leading entry we are supposed to have again should be to the right of it, not to the left. Okay, it must be to the right of it. So any other leading one should be to the right. If there's any other one, also to the right. If there's any other one, to the right. If there's any other one, to the right, like that, like that. Please take note of that. That is how to know a reduced matrix. That's how to know a reduced matrix. Okay, so let's know if this is a reduced matrix. If this is a reduced matrix. Observe this one, there's a leading one. Okay. And every other element in that column is 0. That is fine. But this one is supposed to also be a leading one. Okay, so this one is not a reduced matrix. If you look at this is 1, and every other element in that column is 0. That is fine. And another leading one to the right of it. That is fine. So this is a reduced matrix. If you look at this, when there's a leading one here, the other one is supposed to be to the right, but in this case is to the left. So this is not a reduced matrix. Here we have all the 0 zeros. There's no leading one. So it's a reduced matrix. This one, we have a leading one. We have another leading one to the right, but a row of 0 0 is supposed to be at the bottom. So this is not a reduced matrix. Now if you look at this, a leading one, another leading one to the right, and all the elements in the column are 0 0. Also all the elements in this column are 0 0. And all the zeros are at the bottom. Okay, so this is also a reduced matrix. So that's how to know a reduced matrix. So we are going to be reducing our matrices, okay, to a reduced matrix. Please take note of that.